If you look at the NASA Space Shuttle and the Soviet Buran, they look identical. Most people assume the Soviets just stole the blueprints. But interestingly, when you look at the flight data from 1988, it turns out the Soviet version wasn't a copy. It was a correction. While American astronauts were still manually toggling switches to land a glider, the Buran was performing fully automated, crosswind landings in the middle of a Kazakh winter with an empty cockpit. The real controversy isn't that the Soviets copied the shuttle, it's that they actually built a better one, then left it to rot in a collapsed hangar. But I guess the question is, if the tech was superior, why did it only fly once? The silhouette problem. At first glance, the Soviet space shuttle looked like a stolen blueprint. It had the same delta wings, the same black and white thermal tiling, and the same cavernous cargo bay as the American STS. But interestingly, when the Buran orbiter actually flew in 1988, it did something the American shuttle never could. It launched, orbited, and landed without a single human being on board. If you look at the back of a NASA space shuttle, you see three massive RS-25 main engines. These were the heart of the vehicle, drawing fuel from the external tank to push the entire stack into orbit. But if you look at the back of the Buran, those engines are missing. This isn't a minor design tweak, it's a fundamental shift in how the Soviets viewed the physics of heavy lift. The American shuttle was a man-rated integral system. The orbiter was the engine. But the Soviet engineers at the Energia Bureau decided to separate the cargo from the power. They built the Energia rocket, a modular super-heavy launcher capable of lifting 100 tons into low Earth orbit. The Buran was essentially just a high-tech passenger. This meant that while the American shuttle was a specialized truck, the Energia was a universal power plant. You could strap a shuttle to it, or you could strap a massive space station module to it, or even a lunar lander. The core of this power came from the RD-170 engines on the strap-on boosters. Even today, the RD-170 remains the most powerful liquid-fuel rocket engine ever flown. It used a staged combustion cycle with 4 combustion chambers and a single turbopump, generating nearly 1.6 million pounds of thrust at sea level. Because these were liquid-fueled, unlike the American solid rocket boosters, they could be throttled. They were also designed to be recovered and reused up to 10 times, though that part of the plan never quite materialized. So, while the American shuttle had to carry the weight of its own heavy engines back to Earth every time, the Buran was lighter and had more room for actual gear. It was a more efficient way to move mass. But I guess the question is, if the hardware was more capable, why did it only fly once? It turns out the answer lies in the very autonomy that made it famous. But interestingly, the most significant difference between the two programs wasn't the engines, it was the brain. On November 15, 1988, the Buran orbiter sat on Pad 110L at the Baikonur Cosmodrome. There were no pilots in the cockpit, there were no backup crews. The Soviet engineers had gambled everything on a digital flight control system that, for the time, was decades ahead of its peers. If you look at the NASA Space Shuttle, it was designed as a pilot's machine. The crew was an integral part of the loop, especially during the high-stakes transition from orbital speeds to a subsonic glide. But the Buran was built to be a drone. It utilized an onboard computer system linked to a series of ground-based radio beacons and a sophisticated inertial navigation suite. The 1988 mission lasted exactly 205 minutes. It completed 2 orbits and then began its deorbit burn. As it hit the upper atmosphere, it encountered a massive lateral crosswind, gusts reaching nearly 35 miles per hour. For a human pilot, this would have been a grueling correction. But the Buran's software calculated the drift in real time. It performed a series of S-turns to bleed off energy, and then, remarkably, it executed a hook maneuver to align itself with the runway at the Yubileyny landing strip. It touched down within 5 feet of the center line and only 10 feet from its projected stop point. This was a fully automated landing of a 100-ton glider. It proved that the Soviet Union had solved the problem of autonomous atmospheric flight for heavy-lift vehicles. But just so we're clear, this wasn't just about showing off. The Soviets wanted a system that could launch and return regardless of whether the crew was conscious or even present. They were building a military tool, not just a scientific one. So, we have a vehicle that can fly itself and a rocket that can lift more than its rival. But as you can see here, the physical construction of the orbiter itself held another secret. It was built to survive the heat better than anything NASA had put on the pad. If you examine the underside of a NASA orbiter after a mission, you usually see a patchwork of scars, missing tiles, pockmarked surfaces, and a significant amount of room temperature vulcanizing adhesive used for repairs. But interestingly, when the Buran rolled to a stop in 1988, its thermal protection system was almost pristine. Out of roughly 38,600 tiles, only 7 were missing. The Soviet engineers at the Vyam Research Institute didn't just copy the American silica tile. They redesigned the chemistry. They developed a high-purity quartz fiber with a specific density that allowed for better heat dissipation and, more importantly, a more robust attachment method. They used a felt substrate between the tile and the aluminum skin that acted as a shock absorber. This accounted for the intense acoustic vibrations of the Energia launch, which were significantly higher than those of the US shuttle due to the 4 massive liquid boosters. But the real innovation was in the leading edges of the wings and the nose cap. While NASA used reinforced carbon-carbon, RCC, the Soviets developed a material called gravimol. It was a carbon matrix composite designed to withstand temperatures exceeding 1,650 degrees Celsius for extended periods. If you look at the data from the 1988 re-entry, the Buran's airframe temperatures stayed well within the safety margins, even during the most aggressive parts of the automated descent. And yet, despite this technical superiority in materials and autonomy, the program was already dying. The Soviet Union was fracturing. By the time the Buran proved it could survive the heat of re-entry, the political heat at home was becoming unsustainable. The military, which had funded the project as a response to the perceived threat of the US Star Wars program, realized they had built a Ferrari they couldn't afford to gas up. So, the world's most advanced spaceplane was towed back into a hangar at the Baikonur Cosmodrome. It would never see the sky again. And tragically, the very building designed to protect it would eventually become its tomb. But interestingly, the greatest threat to the Buran wasn't the vacuum of space or the friction of re-entry. It was the lack of a maintenance budget. For over a decade after its only flight, Orbiter 1.01 sat atop an Energia mock-up inside the MIK Building 112 at Baikonur. This was one of the largest buildings in the world, a cavernous assembly plant designed to shield the massive rockets from the brutal Kazakh winters. But if you look at the structural data from the early 2000s, the building was failing. The roof was a heavy multi-layered design, and by May 12, 2002, it had taken on an enormous amount of weight from uncleared snow and soaked insulation. As repair crews were working on the roof, a structural failure triggered a catastrophic chain reaction. Roughly 28,000 square meters of reinforced concrete and steel plummeted 80 meters to the floor. The impact was absolute. The only flight-proven Soviet shuttle was crushed instantly under thousands of tons of debris. 8 workers lost their lives in the collapse. When the dust settled, the pride of the Soviet space program was reduced to a pile of twisted aluminum and broken ceramic tiles. The investigation revealed that the roof hadn't been properly inspected in years. It was a literal physical representation of the post-Soviet space industry. High-tech hardware left to rot in low-tech infrastructure. But just so we're clear, 1.01 wasn't the only orbiter. There was a second one, nearly finished, sitting just a few hundred yards away in a different hangar. And while it survived the collapse, its fate has been arguably more surreal. If you want to see what remains of the program today, you have to look in 2 very different directions. One is a high-tech museum in Germany, and the other is a decaying hangar in the middle of the Kazakh steppe. But interestingly, the most complete orbiter left on Earth, Orbiter 1.02, known as Buran, is currently a hostage. It sits in the MZK building at Baikonur, just a short distance from the rubble of its sister ship. It was 97% complete when the program was killed, featuring a refined cockpit and even a crew ejection system. Today, it's covered in bird droppings and dust, its thermal tiles occasionally stripped by vandals. The ownership is a legal nightmare. A Kazakh businessman named Doran Musa claims he owns the airframe, while Roscosmos has repeatedly tried to repatriate it to Russia. As of 2026, it remains frozen in place, a multi-billion-dollar relic caught in a jurisdictional stalemate. But then there's the OKGLI, the atmospheric testbed. Unlike the orbital models, this one had 4 jet engines mounted to its tail, allowing it to take off from a standard runway. After a bizarre journey that saw it sold to an Australian company and abandoned in a parking lot in Bahrain, it was finally rescued. It now sits in the Technik Museum Speyer in Germany. It's clean, it's climate-controlled, and you can actually walk through its cargo bay. It is the only place on Earth where the Buran's engineering is treated with the respect it earned. And surprisingly, even the unfinished hulls are finding a second life. Orbiter 2.01, which spent years rotting in a Moscow parking lot and later at Zhukovsky Airport, was recently moved. In late 2024, it arrived at the UMMC Museum complex near Yekaterinburg. As we sit here in 2026, engineers are finally beginning the process of restoring its airframe for permanent display. It will never fly, but it's no longer a ghost in a parking lot,